In this lecture, we're going to learn about function declarations and function definitions. The motivation for the topic we're going to be talking about here is that sometimes you really want to separate a function header from its implementation because you don't want to expose all the details about how you do stuff. Let's look at a simple example. In the last lecture, we declared a max function which was computing the maximum between two numbers. The output was an integer, so that's what we returned. The name of the function was max, and we had two parameters, int a and int b. But what we did in the last lecture was crump the entire function body in front of main, but sometimes people don't want to really see the details of how you do stuff. They just want to know a summary of what your function does, what we can get out of the function, and what we need to give to the function for it to do its job. And that's what we're going to see in this lecture. If you look here, we have the function header in front of the main function. And the function header is made up of its return type, the name of the function, and the list of the parameters. And after that, we're going to put a semicolon. This is called a function header or a prototype. And when we do that, the compiler is going to be happy and it's going to work with us to compile our program. But when we get to link our program to really put it together and make one binary, the definition of the function is going to be needed. And if you look after main here, what we have is our function definition. If you look closely, you see that it is exactly the same thing we had in the last lecture. We have our header information. We don't have a semicolon after our parameter list, but we have a pair of curly braces. And inside these curly braces, we have the body of our function. Now, it is really easy to look at this program because we don't have to look at all these details about how this function works. We can get first-hand information on how we can use this function, and that is what most people are going to be interested in about your function. They won't really want to go in and see how you do stuff. They will want to use your function to get the output and use it to do whatever it is they want to do. If you look here in the body of the main function, we have two variables, a and b, and we use them to call the maximum function. We can also set up a minimum function which works in the similar way. And we call another function called incremult, which is going to increment and multiply whatever arguments we pass to this function. So the main idea here is that we can split our function in two parts. One is going to be the function header, which is really going to be the function declaration. And the other is going to be the function body with all the details about how the function works. And that's going to be our function definition. And once we have these two things in place, we can call the function in our main function and do whatever we want with it. Okay, now it should be super clear that we can separate our function in two parts, declaration and definition. And sometimes the declaration part is also called a prototype. That's a prototype of a function, and it is made up of the return type together with the function name, together with the parameters, and after that you're going to add a semicolon to make it valid C++ syntax. And another thing you should know is that the prototype needs to come before wherever it is called. If you're trying to call a function before its prototype is seen in your C++ program, you're going to get a compiler error. And now you might be asking, but why did our programs in the last lecture work? We didn't split things up and our program was working fine. Well, if you put a function definition in front of the main function, that function definition is also going to double as a function declaration. That's why the code in the last lecture worked. Okay, now that you have an idea about what a function declaration and a function definition is, let's head over to Visual Studio Code and play with us. Okay, here we are in our working folder. The current project is function declarations and definitions. We are going to grab our template files like we always do. We're going to put them in place. And we are going to open this guy in Visual Studio Code. Let's do that. We open this up. And we are going to open our main CPP file, clean it up a little bit. And let's close this pane so that we have some breathing space. The first thing we're going to do is set up a maximum function. You already know how to do that. We're going to specify the return type we are going to specify the function name and the parameters. We're going to take in int a and int b, and we're going to go in and do whatever we need to compute the maximum between these two guys. We're going to say if a is greater than b, then a must be the maximum, so we're going to return that. Else, we are going to return b. Okay, this is the function, and it is really simple. We can go down in main and use it. So let's say int x and put in a 5, for example, and let's say y and put in a 2 or a 3, put in whatever you want. And then we're going to set up the result variable, which is going to catch the maximum. I think we can do that. And what we're going to assign to this is whatever is returned from our function call. So we're going to call this function with x and y. So we're going to be computing the maximum between 5 and 2 here. The maximum is going to be stored in this result variable, and we're going to print it out. So we're going to say std cout, and we're going to say max as result. This is going to do. Okay, let's try and build this and make sure it actually works. This is nothing new so far. It is everything we have done in the last lecture. Now the build is good. We can clear and run Rooster. We're going to get the maximum as a 5 here. And if we try to change these things, for example, make y a 12 and build again, we're going to use GCC. And we are going to clear these things and run Rooster. We should get max equals 12. This is all fine and dandy. But sometimes we don't really want to have the details about how our function works shown in front of the main function here. And we can split our function in two parts, a declaration and a definition. The declaration is really going to be the header part of the function, and that's going to be the return value, the name of the function, and the parameter list. But to make it a valid declaration, we have to put a semicolon after this. So this is our function declaration. Sometimes it is also called a prototype. And please make sure you understand the difference between a prototype and a signature. In the last lecture, we saw that a signature was only made of the name of the function and the parameter list, but the return value was not part of the function signature. But the prototype includes all these guys. So signature doesn't include return type. Okay. So now that we have our function declaration set up, we need to put in a function definition, because if you try to compile this program and link it, you are going to get problems. Let's try and do that before we put in the definition. We can build with GCC. We are learning, so we don't have to fear breaking things a little bit. Let's clear and try to build with GCC. And you're going to see, we have a problem here. And what kind of problem we have? The C++ compiler is going to compile this program, but when we hit the link stage, I realize I haven't really talked about this in more detail, but we will do in this lecture. But the main problem here is that we don't have the definition of this function in place, and the compiler is going to search for it and not find it. And you see that it is saying undefined reference to max. Okay, so it has seen the declaration of the function, but it doesn't know how the function does its job because we don't have a function body in here. So to really make this code work exactly as we want, we need to put in a definition. And the definition can show up anywhere in your C++ program. In this case, we're going to put that after the main function. And the definition is really what we have been using so far as our function definition in the last lecture. But notice that it has the body information. And now when the compiler tries to compile this program, it will know how the maximum function is computing its maximum because we have all that information in here. So let's say that this is our function definition and shows up after main in this case. And we can try and build this and see if the build is good. Now you see the build is good. And if we try to run it, we're going to get our maximum exactly like we did when we had the declaration and the definition cramped up before main here. But hopefully now you can see that our program is much cleaner, because when you look at this, you know that we have a function called max. It's going to take two parameters. It's going to return something, and it is called max, so it must be computing the maximum of these two guys, but we don't really care how this function does its job, how it computes the maximum here. And this is the main message here. We can split our function in two parts, a declaration and a definition. Okay, just to play around, we can also set up a minimum function. Before we do that, let's set up its definition down here. We're just going to copy the maximum and adapt it. We're going to put a copy of that guy here. We're going to call it min. It's going to take two parameters. It's going to return an int. But what we test for is if a is less than b. If a is less than b, then a is our minimum. If a is not less than b, then b must be our minimum. And we can put the declaration of this function on top here. So let's go there and say min and say int a and int b. And now we can change the call here to say min, and it is going to compute the minimum. Why not? Let's do that. We're going to say min here, and we're going to grab whatever is the minimum between x and y here, and that's what we're going to have in this result variable here. Let's do that. We're going to try and use this. The build is good. So we're going to clear and run rooster. Now the minimum is 5. We are calling our minimum function. In the last lecture, we also set up a function to increment and multiply. Let's try and do the same thing, but split that into a declaration and a definition just to practice a little more. We're going to call this increment, and it's going to take a and b in, and inside, and we're not going to put the body on top here. We're going to put the body down with the other definitions that we have for all these other functions for max and min here. So we're going to put in our body. It's really simple. So we're going to put a body inside these curly braces, and we are going to return plus a. We're going to increment a, and we're going to multiply that with an increment of b, and we're going to return that. I think this is going to be valid C++ syntax. And if we try to call this function in main, let's do that. Say increment, and we're going to pass in x and y. The program is going to just work fine. We're going to grab the result and store that in our variable. Let's do that. And we can print the result. And we're going to say result here. This is going to do. And if we build and run this program, we're going to see the output here. Let's see what we get. The result is going to be 78, because if we increment a 5, it becomes a 6. If we increment y, we're going to get 13. 13 times 6 should be 78. Let's be sure. We're going to bring up a calculator. Let's do that so that you know that I am not making these things up. 78. So our program is really working like it should. And this is the main message here. We can really split our functions into a declaration and a definition, and that's going to make our programs much easier to work with and read. One thing you should know is that the names of the variables aren't really important in function declarations like this. So for example, we can take out the a and b here, or we can take out all the variable names in our function declarations. Let's do that. And you might think, is this program going to compile? Well, I hate to break it to you, but it is going to compile. So let's build with GCC. You're going to see that the build is good. So the function header or declaration doesn't really care about the variable names. In the definitions, we care about these variable names because we are going to be using them in the bodies. But if you want, you can leave them out in your function declarations. But I like to keep them in place because I like my functions to be self-documenting. If somebody looks at this, they will know the variable name here. But if you really want, you can leave the variable names out, and it is going to work pretty well. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see how we can split our programs in multiple files now that we know how to split into declaration and definition. Go ahead and finish up here and meet me there.